I will show you a group activity in which students learn about melting. It is designed to connect the previous idea that heat is jiggling molecules with the real experience of observing things melt. Students will also look at digital animations and connect their observations to the fact that it takes energy to pull toy atoms and molecules apart. Once set up, students will need to take temperature measurements every half an hour or so, over several hours, so plan your other lessons with brief breaks for their measurements. Start by posing the question to students: what happens to ice when it is taken from a freezer and left in a glass on a table? Each group will need some ice, a clear glass, a thermometer, and access to a timer or a clock. For the ice, you can use either ice cubes or crushed ice. Students then fill their glass 3/4 full of ice and measure the starting temperature of the ice. It is difficult to measure the temperature of solids with this type of thermometer, so it works best if the thermometer is placed in the center of the ice, like this. Students may need to wait a minute or two for the measurement to become stable. You may also like to record the temperature of your freezer or icebox, as well as the room temperature for comparison. Ask students to record the time, temperature, and any general observations each time they take a measurement. When they have taken their first temperature reading, do the whole class change of state activity, described in the lesson plan. Then, return to take the temperature and observe what has happened to their glass of ice. You should aim for students to take temperature measurements once every 20 to 30 minutes. Following the second observation, use digital animations of how water molecules move and are arranged in ice and water to reinforce the learnings from the change of state activity. In ice, the water molecules are neatly lined up like oranges packed in a box, but they are still jiggling a bit, just like how students stay on their grid position and vibrate backwards and forwards during the change of state activity. When the water melts, the molecules are still close together, but they start to move randomly around, mingle amongst each other, and bounce off of each other. This explains why the ice is a hard solid, but once it melts, the water flows and collects at the bottom of the glass. When all of the ice is melted, and the glass only contains water, notice what happens to the temperature. We see that the temperature of the ice increases until it reaches 0 degrees Celsius. Then, as the ice melts, the temperature surprisingly remains close to 0. This is because all of the heat energy absorbed from the jiggling molecules in the surrounding air is used up in the energy needed to pull the molecules free from each other. Only once all the water molecules are free from each other can the jiggling of the air molecules cause the water molecules to start jiggling more, and the water begins to warm up. Then, the water only stops warming up when the jiggling of the water molecules balances out with the jiggling of the air molecules. At this point, the water temperature will be exactly the same as the air temperature. This activity might be a good opportunity to introduce students to plotting data on graph paper if you haven't previously introduced students to making dot plots. Here is an example of a dot plot you might expect from this activity.